Okay, let's do some homework questions. So over the weekend on this sheet, projectiles fired at an angle, you had 4, 5, 6, and 7. So let's look at number 4. It says a baseball player throws a ball into the air at an angle of 30 degrees and with a speed of 50 meters per second. How far does it land? Oops, be good if I had. How far away does it land? So you're looking for delta dx. Okay, so we can do our x and y. And in our x direction, we have vix, which is going to be vi cos theta. And we have ax, which is going to be 0. And we have delta dx, which we're looking for. And of course, we don't know delta t. In our y direction, we have viy, which is equal to vi sine theta, and that'll be up. We have ay, which is equal to 9.81 meters per second squared, and that'll be down. And the only other thing that, well, we don't know the delta t, but it'll probably be the delta tu that we'll want to find. And then from that, we can find our viy. So because it's ground to ground, we can start with our up, and we can do ay is equal to vfy minus viy over delta t. And if we start with our up, this will go to 0. And we know viy, we know ay, so we can find our tu. So delta tu will be equal to negative vi sine theta over ay. So delta tu will be equal to 50 meters per second sine of 30, and there's a negative there, over negative 9.81 meters per second squared. So on the top we have 25, on the bottom we have 9.81, the two negatives disappear, and we get something like 2.55 seconds. And so the total time will be 5.10 seconds. Okay, so then once we have that, we can go back and find our delta dx. So our delta dx will be equal to vix delta t, 1/2 ax delta t squared. This side goes to 0. So delta dx is equal to 50 meters per second cos of 30 times 5.10 seconds. And so delta dx is equal to 220.7 meters, which I'm hoping is what I have as an answer on the sheet. Look at that, it is. Now, I could double check this. 25 divided by 9.81. It's always good to not do this in my head. Yeah, so I rounded that a little. So it was 2.548 times 2 times 50 times the cos of 30, and it works out to be 6996. So I didn't round it too much, so all's well. All right, number 5. A projectile hits the ground 10 seconds after it was fired from the ground. So again, it's going to be a ground to ground. Okay, so it's going to come up, it's going to go down, and it hits the ground 10 seconds after it was fired, and it moves a horizontal distance of 600 meters. So our delta dx is 600 meters. What was the original velocity of the projectile? So in the x, we don't know our vix this time. It should be vi cos theta, but we don't know either of them, so you might want to just leave it as vix in your unknowns. Ax is 0. Delta dx is 600 meters, and delta t is 10 seconds. In our y direction, we don't know viy, and again, you might just want to leave it as vi and not vi sine theta, because that way it doesn't introduce two unknowns. Ay is 9.81 meters per second squared. This will be down, this will be up. And we know our delta tu is 5 seconds. So in our x direction, we can do delta dx is equal to VIX delta t, 1/2 AX delta t squared. This goes to 0. VIX is just going to be delta dx over delta t. So 600 meters over 10 seconds. So VIX is going to be 60 meters per second. And then in our y direction, we can use AY is equal to VFY minus VIY over delta t. And if we look at the up, this goes to 0. This is TU. So our VIY will be negative AY delta TU. So our VIY will be negative 9.81 meters per second squared times 5 seconds. So our VIY will be 49.05 meters per second. Whoops, ignore that squared. And once you get that, then you do, in the x direction, 60 meters per second. In the y direction, 49.05 meters per second. And then you square them, add them together, take the square root, and find the angle. And when you do that, you should get a VI of 77.5 meters per second, and your angle should be something like 39.27 degrees, and that will be WRT with the ground. Okay, so that's number 4 and number 5 from the sheet. All right, I'm going to stop there, and we'll do the next 2 in a separate video.